Hello, good morning, sir.
Good morning, Srichandan sir.
Good morning, Sasang sir. Good morning.
Uh,
Good morning.
okay, joined at the right time.
So, shall we start, sir?
Just after the introduction, we will start.
Okay, sir.
Members are joining.
Okay.
Hello, sir. Good morning to everyone. Hello, I'm audible.
Yes, audible.
Yeah. So, good morning to everyone. So, I, Panigrahi Srichandan, working as an assistant professor from GMR IT. So, today, day two, online national FDP on emerging research trends in computer science and engineering. So, that today's day two topic, the cyber Day 2, so cyber physical systems. Dr. Srichandan Sobhanayak, he's working as a assistant. So now introduce Dr. Srichandan at IIT Bhubaneswar, IIIT Bhubaneswar. He's working at IIIT Bhubaneswar since 2016. He has 15 years of teaching experience. He did his MTech and PhD from NIT Roorkela. His research interest includes cloud computing, IoT, Internet of Things, and blockchain and cyber physical systems. He has published 18, 18, uh, ar- 18 journals of articles, international journals, and he published international journals and conferences, reputed conferences. He has delivered expert talks in FDPs organized by Bhubaneswar University of Technology and at Odisha, and other institutions and organizations also. So now coming to topic, the topic is uh, cyber physical system. So cyber physical system. So today's webinar topic is cyber physical system. So cyber physical system, which is mechanism is controlled or monitored by the computer system based on in physical systems. The physical and software components are deeply embedded and able to operate on different spatial and temporal scales to exhibit and multiple distinct behavioral mobilities and interact with each other. Two ways of change context. For example, the CPS includes smart grid, autonomous and automatic mobile and medical monitoring and industrial control systems and robotic systems, and finally the automatic collect awareness. So these are the introducing of cyber physical system. So I I would welcome to Dr. Srichandan Sobhanayak sir. Welcome sir. Over to Sobhanayak sir. So
Yeah, thank you, Professor Srikant. It's an immense pleasure that to become a part of such a national level FDP organized by our GMRIT management, and I must be thankful to Professor Gontait for giving me this opportunity and to become a part of such an event, and also deliver a talk on cyber physical system. And I'm Professor Srichandan Sobhanayak. Almost everything has been told by Professor Srikant, and nothing to continue more about this. And just to add a few things, as my research area includes cloud computing, IoT, blockchain, and cyber physical system, we can work collaboratively to collaborate in this research area in future. And my email ID is srichandan at IIIT-bs.sc.in, and if any faculty members or any of the professor would like to work in collaboration with me, and we can start up the work, it would be my great pleasure working with you professors. And in today's lecture particularly, I will be delivering a talk on cyber physical system. Whatever things that I am going to deliver is very minimum. There is a there are a lot of things that we can learn out of this cyber physical system. Okay, so we will start. We will discuss only the fundamental things, and rest. If anybody is interested in this particular area, can explore and can go into in depth by looking into some journals and looking into some other materials that is available over the internet and in and around us. So thank you. Let's start. Let's start today's presentation.
thank you sir.
Okay. Now, cyber physical system. When these things comes to in your mind, first of all, there are basic things that we need to answer. The basic question that comes to in our mind. Okay, what exactly cyber and what is physical and physical system and all those things. Before getting into this cyber physical system, just we have to go back in the year of 1940 and 50, when slowly the computer has taken birth. What we say, the digital computer has taken, but the generation of computer has taken birth. And from that day onwards, people have ever thought of about automation of things, automation of the scenes. As you all know that wherever there is the involvement of your human beings, it leads to error, or it leads to error. Why? Because as you all know that human beings are constant with their own energy, or human beings are constant with their age limit. Human beings are constant with their brains, powers, and all those things. So whenever human beings are a part of any production system, or part of any industrial system, or part of any other activity, that leads to an error because of the constant associated with human being. All these things. So time and again, there are some critical situations where the risk factors are more. There are critical situations where the risk factors are more, where the involvement of such human beings may lead to a great devastation. So, or it may lead to a great loss. It may be an industry, or it may be any other field that works in a real-time system. So, to overcome these things, what has been done is that in early days, people has to think about some alternation for this human being. So they used to think that what can be done so that we can minimize the usage of, or we can minimize the involvement of human being in a particular activity, and increase and put some other things that can work rigorously, that can work tireless, and that can work without error, and that can also minimize the risk, that can also minimize the cost, that can also increase the productivity of your system. So looking into this, there are certain drawbacks associated with the human being. There are certain things. There are so many objectives associated with a particular system or particular organization or a particular industry. So to achieve those objectives, maybe if you consider human as a part of its system, then we have to take care of we have to face certain risks. Risk in the sense leads to error, because human beings may be tired, or because of that your production system may get slower and all those things. So keeping all these things in the minds, with the advancement of the technology, people have thought of replacing these human beings and start doing things automatically. That means evolution of your automation systems. Okay, now just we have to go back in the year of 1914, 40 and 50, in and around, well, the first generation of computer have been started. Before the computer have been started, there are many other systems that exist, electronic systems that used to exist in the market, but they were not such efficient, or as the technology were also in its infancy, it was not so advanced. So what happens, people were used to hesitate to adopt this technology into their systems. But when time and again, when the technology has been advanced, people now are more eager to adopt this advanced technology into their system and remove this involvement of human beings into the system, which may lead not only to errorless environment, that also leads to increase the productivity of the system, that will also leads to increase the profit margin of the system, or that will also also will help the system to maintain their profit margin in a balanced way. So keeping those things in the mind, the automation in the mind, the main motive behind the cyber physical system is to keep away human beings from the system and make the system automation as much as possible, so that everything should run smoothly, and that will lead to an environment where the environment is completely error free, that will run smoothly, increase productivity, minimize the cost, increase the property. These are the so many objectives that can be fulfilled with the automation or with the involvement of your cyber physical systems. So keeping those things in the mind, the cyber physical system has already been started right from the generation of your computer. Now we have to just imagine how this generation of a computer helps to go adopt the system of automations. Now if you go back to early days, we used to have mechanical system or electronic systems. So these whatever industry we used to have, or whatever things, industrial things that we have in and around us, they either used to adopt either mechanical system or electronic system, or together they can make it a mechano-electrical systems, which is a combination of two different fields. That is what mechanical and electrical or electronics field. So if you just imagine the early days computer, the first generation computer, it used to have a vacuum tubes, which is of big size. We cannot adapt a system simply just you cannot just adapt a system which is very costly for us. If you just go for the first generation of computer, it used to be a large in system, which is nothing but a vacuum tubes. Now if you just think about a system today, and the circuit associated with the system, it is very minimum. The nanoparticles come into the existence. So, and that too, this nanoparticles is very cheaper compared to the vacuum tubes that used to come in early days. So the advancement of the technology, right from the vacuum tubes to the integrated circuit, and today we have in and around us ASIC processor. What the ASIC processor, what we say is the application specific integrated circuits, where the kind of application that we need, based on that we will be designing the circuits, or we will design the chips for that particular application, and that can fulfill our purpose. It is not necessary that we will design such a circuit. It will have so many properties, it will have so many facilities. It is not required, because sometimes what happens, if we have a system which is having multiple property, that may lead to hazardous situations, or that may create a problem, because and sometimes the production cost for that kind of chips may lead to higher cost. So instead of going for that one, if you go for designing such a chips which is very application specific, depending upon my application, I will design a chips, and that will come in a very minimum cost, and I can apply this these chips to my application. I can increase my productivity, I can increase the efficiency of my system, and I can increase the profit and many more things related to my system. So thinking of all those things, right from the technology corner, right from the and system point of view, right from the technology point of view, the cyber physical system plays the cyber physical system plays a vital role in our technical field. Now, so this is what exactly the basic introduction that we can have. Why is the why we have cyber physical system in current scenario? The cyber physical system come into the existence. Currently, we are thinking about cyber physical system, but the cyber physical system was there. It has already been started right from the generation of first generation of our computer system. But the technology, but people used to hesitate. People used to feel reluctant to adopt this technology into their lifestyle. Why? Because there are many things. Right from nobody can afford a vacuum tubes in their system to automate their system, to automate their organization or anything else. So which to be very costly in the nature. But today, if you ask someone, you can purchase an IC which is cost of and then around 1,000 rupees or 1,500 rupees to create an automation for the system. They can easily go for that one. Why? Because it's very cheaper in the cost and it is very application specific, and we can go for designing of such a system.
Srichandan sir,
Yes, sir.
that slide is not only
Moving?
first slide is only available.
I'm in the introduction. I'm yet to get into
Okay,
the.
okay, okay, okay,
Okay, I'm the
okay,
first.
okay.
I'm not. I'm yet to start my lecture right now. I'm just giving a brief
Okay,
introduction. Okay.
okay, thank you.
Yeah. Now it is sliding, right? Is it sliding? Professor Sasank sir, is it sliding? My slides are going down. Hello, am I audible?
Yes, sir, you are audible.
The slides are going down.
Going down.
Yeah, thank you.
Yes, yes, you are moving.
Yeah, it's going down.
Okay.
Thank you. Now, so this is what exactly happens in your cyber physical system. So let's start in-depth analysis of your cyber physical system. So during this session, what I'm going to do is that we'll be discussing what is the evolution of your cyber physical systems, and what are the challenges that were there that has been addressed by your cyber physical system that we are going to analyze in this, and basic architecture of your cyber physical system that we are going to analyze on this FDP, and in the last we'll try to find out some of the research challenges, because we all are academicians. Okay, we are most focused on the research part of it. Okay, how this cyber physical system is helping us, how can we work on the cyber physical system in the research aspect that we are going to see. We will see some of the research challenges associated with the cyber physical system, so that in future, if any professor wants to work in collaboration with me, so we can extend those works in future. This is what a part of our discussion. In the last, I will discuss a paper that I have published in a journal related to a cyber physical system. We'll discuss, and we'll wind up the things. Okay, so this is what is the organization of this FDP. Organization of this particular FDP. Okay, let's start in-depth analysis of your cyber physical system. Basic introduction. The term cyber physical system was initially coined by Alan Gill in 2006. The person Alan Gill has invented, he has only given the name in 2006, but it's not 2006. The generation of your cyber physical system, the other name of your cyber physical system is nothing but your automations. It's already been started with the generation of your first computer. Rather, because the technology was not so developed, so technology was in its infancy, so people used to hesitate to adopt this technology. So with the advancement of the technology, people when started adopting the things in their systems, then people have named them as a cyber physical system. So Alan Gill is the first person who has coined or pointed out the relation between your cyber and the physical system. So the cyber physical system nowadays, a commonly accepted definition for CPS, it's an embedded systems of integrating the physical and digital worlds by establishing global network for business, and providing real-time data accessing and data processing services. Now, the cyber physical system, we can say that it provides an integration of physical and a digital world. Okay. Now, what is a now, this cyber physical system, what exactly is cyber meaning? Cyber is nothing but it is associated with computation or computer communication and controlling these some of the devices using some techniques, algorithms, or some of the techniques. And normally this exists. All these are involved. Either it may be a discrete or logical, or it's based on your switch-based system, or it may be consisting of a network, and these networks will consisting of some of the devices. These devices are has capability of computation. These devices has capability of communication, and these devices has capability to control the all over the system that exist in the network. Or this is what exactly your cyber is nothing but what we say is the, in very simple language we can say cyber is nothing but a small computers. Okay. Now, what is a physical is nothing but a natural and human made systems that follows the physics or any other basic science properties or characteristics. That's what that exists in and around us, where a people or a human being wants to study its nature in and around us. So what is a cyber physical system then? Then using this computer system, instead of involvement of your human being, we will use some of the computer system that can access the characteristics that we have in and around us, and we can study the things and we can react depending upon the situation that we are going to face. So integrating this cyber and the physical system, what we are going to get is the cyber physical system. So if you just analyze this cyber physical system, it has already involved in since 1950. So if you just observe this graph, you can see, observe this graph. It has already started in the year with the advancement of your mechatronics. What is the mechatronics? Nothing but it's the involvement of a mechanical system and electronic system in the year way back in the 1940 or 1950. In this era, this has been mechatronics has already been started. This is a kind of automation system, because when the first generation of computer started with these things, the automation system has already been started. But whatever automation system that used to have, it was only in its infancy, because as you know that the technology was not so developed. So people used to hesitate because there used to have so many risk factor involved in this one. So people don't want to take any sorts of risk. So, but still there used to have automations in those days. But in yesteryears, whatever we used to say an automation system, today we name them as our cyber physical system. Okay, so it has started with the involvement of your mechatronic systems, then it has moved to cyber physical systems. Then currently whatever we are using is your cyber based systems, that includes your IoT, where we have number of applications of this related to your cyber physical systems. It may be your aviation industry, it may be your automobile industry, it may be healthcare. Where not, just you think of some application that we can use this cyber physical system into that one to make it automation to work using your artificial intelligence and all other things. So basic objective of your cyber physical system is to just remove the involvement of a human being in a particular system, make it error free, make it efficiency, minimize the cost, and increase the productivity of your system. So this is what is the generation of your cyber physical system. How it goes, it started with a mechatronic system, then it goes to cyber physical systems. But during these days, right from your mechatronics for this transformation, right from mechatronics to your cyber physical system, there has been a lot of changes that you used to have. In those days, we used to have vacuum tubes in our computers, and we used to have embedded systems. And these embedded systems used to come very cheap, very small in size with the advancement of the things. But the thing is that there used to have many challenges with these embedded systems. What are the main challenges that used to have? First thing is that heterogeneous in nature. And the second thing is that there used to be a scalability issues. Scalability. What is heterogeneity? Now we do not have any standardization organization that they can make it standardized, so that we can use these devices universally without facing any error. So because of because there is a heterogeneity in the devices, to adapt the things, it will create a problem. Because for each and every embedded system, we used to have different operating system for this one, and for to understand each and every operating system, we need to understand its instruction set, and to understand its instruction set, we have to go through detail. Let's suppose say that we have 100 different types of embedded systems. So to run this embedded system, we have to have our own operating system for this one. To run this operating system, we have to understand the instruction set associated with this one, which is a very tiresome. So what the thing is done is that with the development of your technology, slightly this heterogeneity concept has slightly been neutralized, and people have started adopting a neutral language or neutral technology that will, by understanding a particular one technology, you can adapt any other things that is available in our society. Okay, so this is how exactly the involvement of your cyber physical system, right from mechatronic system and cyber physical system, then we have cloud. Okay, so this is an abstraction that we have. Okay, mechatronics and devices and all those things that we have. Then with the advanced technology, we have cyber physical system. Then today, whatever you are seeing in and around us is Internet of Things, smart building, smart healthcare systems, smart avionics systems, smart automobiles. Wherever you go, we find a smart. It's only possible because of this advancement of your technology. Okay, what is the advancement technology we have got? ASIC processors, advanced application specific integrated circuit, which is very, depending upon my application is healthcare based system. So depending upon that healthcare, what I need to have in my chips, or what I need to have in my integrated circuits. So depending on that one, it will be designed. Let's just think for a moment like that. Okay, if I'm going for a small application, like think for accessing the temperature in and around us. So to access this temperature, maybe the size of the data related to this temperature accessing method, maybe 1 byte, 1 bit, 1 byte, 2 byte, or 2 byte, or maximum of 1 kilobyte. So to process this 1 kilobyte of data or 1 byte of data, I don't have to have a processor of 2 gigahertz or a processor of 5 megahertz or a processor of bigger size. Even if a small processor which is of which is having a small capacity, that is more than sufficient to process a data size of maybe 1 KB or 1 byte or 1 bit. I don't have to have a desktop to process all these things, or I don't have to have a cloud which is of having higher capacity and high-end processor. Like that kind of thing. So my application is very specific, and the data that is coming out of a particular system is maybe of size of 1 bit and 1 byte or 1 kilobyte. I don't have to have to process this data. I don't have to have a cloud system. I don't have to have a desktop to process this one. I just have to a small system. It may be a Raspberry Pi, or it may be your Arduino, or any other things which can process the data then and there itself, and it can give you the result, or it can provide you the solution for after analyzing the data from your environment. So the advancement that has been done with the technology makes it much easier and easier people to go for adapting the automation technology. And as you all know that the technology is not concerned with a particular system. Now what exactly I mean to say is that the technology, whatever cyber physical system we are thinking about right now, it doesn't belong to a particular kind of engineering, or it doesn't belong to a particular kind of basic science kind of thing. It is what is a integration of, or what we say, integration of different branches of engineering. Like that, in yesteryears or yesterdays or yester months, what we used to have different branches of engineering. Some people used to say, I am in mechanical engineering. People used to say, I am in electronics engineering. People used to say, I am in computer science and engineering. But a day will come, they will say that I am in a branch of engineering that is called cyber physical engineering, where it is an interdisciplinary system which is a combination of not only computer science, not only electronic system, not only mechanical engineering, or not only it belongs to a physics, or it's a mathematics. It's a combination of interdisciplinary system that will give rise to a general branch that will lead to your development of your cyber physical system. Let's suppose say that if you think about artificial intelligence, no one can claim, not a single branch can claim that artificial intelligence only belongs to computer science, or it can be only applicable to computer science, it can be applicable to only mechanical or electronics, nothing like. Artificial intelligence is applicable to whichever field, it may be civil, mechanical, electrical, computer science, whatever it is. It is required for all over the field. So because this development of your your interdisciplinary subject. So we cannot say that in the time and again, when one day will come, people will say that people will not be identified by the individual engineering branch, rather they will be identified a particular engineering. That's what we will say is a cyber physical engineering. Okay, so this is what is that that the cyber physical system has contributed to the development of our technological systems. Evolution of your cyber physical system has given or contributed to the development of your such a interdisciplinary kind of thing, where the involvement of where there is a multiple disciplines that involves in this area to develop a particular system. So this is what. So now, as you all already say that this is the cyber physical system is nothing but it's an embedded system. Okay, you all know that this is what embedded system. If you see the embedded system, the lesson of the embedded system, these are very small devices. Okay, with small processing capacity, small memory size, and but they can do a bigger work. So when technology has been advanced, we have been advancing the embedded systems with coming out. So today in and around whatever we see in and around us, it is nothing but our embedded systems. It may be your cell phone, it may be your any automation of vehicle automation, it may be anything that we have in and around us, nothing but an embedded system that comes along with your operating system, memory and processing capacity, that solves many issues, or that make easy, that make the things much easier and makes the life much and more comfortable. So you just imagine, you just close your eyes and think some application in and around us that may be associated with some embedded system associated with. You think for a moment, this is an automation car system. This is a car system where inside this we have an embedded system that controls everything, even right from starting off your engine to close your doors to make it automation drive and everything that we have an embedded system. That is also what we say is the cyber physical system. This is related to your automobiles. Now come to your aeroplanes and all these things. They are the autopilot and many more things associated with your aviation industry that leads to your embedded system, which is also a cyber physical system. You think from today in and around us, there are so many smart mobiles and phones and with us. What is that? What exactly is that? That is nothing but a cyber physical system in and around us. And for entertainment we have, and for medical systems collecting data from in and around us, and right from in the military we have, in our defense system we have all these things, and monitoring environment, okay, climates and all these things. Just close your eyes and think of some application, okay, that will be associated with your embedded system, and this embedded system leads to your cyber physical system. Okay, then if everything, as I already told you, that just close your eyes and think some application that leads to your embedded, that leads to your cyber physical system, then everything is cyber physical system. But there are something which are not cyber physical system that we need to identify. What is that? A desktop computing is not your cyber physical system, okay, and traditional post-hoc embedded systems is not your cyber physical system, and today the sensor network is not your cyber physical systems. So these are some of the things that is not a part of your cyber physical systems. So now we will identify what exactly the characteristics of your cyber physical systems. What is associated with it? Then if these are not the characteristics of a cyber physical systems, these are not the part of the cyber physical system, then what are the different characteristics that we have in our cyber physical system? The first and the foremost is that cyber capability in every physical, the characteristic that includes in your cyber physical system is that every physical component can be associated with your cyber capability. Cyber capability in the sense we can control any physical component using your computer or using your any embedded systems. So not only that, the first thing is that all the physical component can be controlled using a computer. Okay. Second thing is that if we have different cyber physical system in and around us, they can be put together in a network, and we have a centralized control over these components and make it controllable right, sitting in a remote area. Let's think for a moment that in a defense area, there are so many areas in the defense where we cannot go and surveillance those area right at the place, and those areas need to be surveillance at the remotely, and because there are some places we cannot go, like the hilltop of your Himalaya, or there are some places that we can Sachin and all those things that you cannot go over there, but we need to define some of the techniques where we can sit remotely at a distance place, we can manipulate the things. So creating this to make it a surveillance of those kind of systems using your cyber physical systems, and make a network of those systems sit and controlling or monitoring or surveilling those systems sitting at a remote place is what is the characteristics of your cyber physical system. That means not only it is an individual cyber physical system, we have to create it a network, and sitting at a remote place we can control also those cyber physical system remotely. Okay. Then as you all know that it is associated, there is another characteristic associated with this, with your cyber physical system, is that complex at multiple temporal and spatial scales. Yes, obviously it is a complex in nature. Why? Because there exists an heterogeneity in the devices. So the device, which as I already told you that we have different sorts of applications, and depending upon the application we design the embedded system or the chips. With the advancement of your processor like your ASIC processors, application specific integrated circuits, we have heterogeneity in the nature. There are a lot of things. Even if today the cyber physical system is in fancy, okay, there are some standardization that must be done so that this complexity that we have in our system can be minimized. Okay, then this is what raises out of your heterogeneity. Then second, next point is that dynamically reorganizing and reconfiguring the things or cyber physical system. That it should whatever dynamic cyber physical system we have, we need to reconfigure it or reorganize it dynamically. So here what exactly it's saying is that we need to minimize the involvement of your human intervention of your human into the systems. So things has to be done dynamically, where we can done, and this thing can be done by using your artificial intelligence and some other technique through which the machine can detect or organize itself or reconfigure itself depending upon the situation that it is going to face in the surveillance area or in the place where it is kept to retrieve the data from the environment. So this should be a characteristics of your cyber physical systems. The next important characteristic is that it should have high degree of automation. High degree of automation. More is the automations, more is your less is your human involvement. But we cannot just go for an automation. There are many other risk factors is also associated with this one. We will analyze what are the risk factors. But thing is that if we have more degree of automation, then human involvement will be more and productivity will be more. Okay, so this will be a these points pointed out characterizes the high degree of automation, which minimizes the human involvement. Okay, and next point is that unconventional computation and physical substrate. Okay, so the computation parts that is associated with a particular system should be there are many unconventional way that is associated with the computation systems. So that has to be characterized in your cyber physical systems. And next is what we have: operation must be dependable, and it must be certified. What exactly is dependable and certified, we will see in our next few slides in this FDP. Okay. Now next is your goals of a CPS research program. As you all know that this is a new paradigm for the technology, cyber physical system, a new science of future engineering and monitor control physical systems, right from the vacuum tubes to the embedded system that we have in and around us. So we have to think, there are lot many challenges or lot many science, engineering challenges that thing is that the physical and cyber design that is deeply integrated. So we are yet to we are yet to explore the nature or the physical system that we have in and around us. Okay, depending upon that, we have to define or design the computing, communication, and control system for that particular environment. Okay, so this is so this there exists a research problem on understanding the environment and surrounding in and around us that should be well integrated with your computer system to design your cyber physical systems. next next comes to your the architecture, or what we can say is the layer of your cyber physical system. It consisting of 3 layers. Okay, the first is your perception layer, second is the upper layer of that deals with your communication, and third is your application. Okay, what is a perception layer? This perception layer, then there are many as I already told that this is an interdisciplinary subject, or this is an interdisciplinary field which is a combination of so many things. So in the perception layer, what we can say, there is the physical layer of ISO-OSI model. What it consists of? It consists of all sensor nodes, RFID, and actuators, all these devices or physical devices associated with this one that interacts with the physical systems to collect the data and process it depending upon our requirement. So this perception layer is almost equivalent to a physical layer that consists of your GPS system. That with this GPS system, we will try to locate a particular device or particular things in and around us. RFID, which is also a part of your perception layer. It may be sensor network, or it may be actuators, or sensors and actuators that works together to generate a particular amount of data, or IoT devices that is present in and around us. Okay, now after this perception layer, we have a communication layer, because to provide this communication, we can use any of the network. Like in the network layer, we use some internet protocol or some protocol to facilitate the communication between the source and the destination. As you already, if you have some network idea, that network layer is the responsible connecting source and the destination. So this communication layer, what it is going to do is that this is going to provide a communication between the device that is present in the remote area and the device which is going to access the data from sitting at the remote area. So to facilitate this communication, we can use either a wired network, it may be a wireless network, or it will consisting of network devices. Okay, so this is going to constitute our communication layer in your cyber physical systems. So next comes your application layer. Application, there are numerous applications. Just close your eyes, think of something, and that becomes an application. So what we have application of your cyber physical system in your smart building, creation of your smart building, creation of your smart city. It may be smart industry or healthcare system, smart grid, vehicle, aviation. So many. The applications are numerous. Okay, so the basic objective is that development of this cyber physical system is that we have to remove the involvement of your human beings from in and around us, and we have to think about some advanced technology that will minimize the error and increase the productivity, minimize the cost, and many other things. There are many things has to be optimized by adopting this new technology, that is cyber physical systems. Now next, why is the CPS, cyber physical system, is significant? Obviously, if there is no significance of a particular technology, why should I adopt it? And what is its significance in our day-to-day life? So there are many significance that we have. It is applicable to any field that exists in and around us. Okay, it may be your automotive, it may be your avionic or aerospace, it may be industrial automation, or it may be a telecommunication system, or consumer electronics, or intelligent smart homes, and healthcare and medical equipments, or electronics. It is observed that 53% of the cost has been minimized by adopting by these industrial systems. Okay, and as I already told, that this automation system has already been started in the year since 1950. That mechatronics. Okay, but it was very, people used to go for automation very low because technology was not so advanced. Computer technology has not been so advanced. So that's why people used to hesitate adopting this one. But today the scenario is completely different. The chip size is different. Cost of a chip, it comes in around 1,000 rupees or 1,500 rupees. Anybody can afford it and anybody can go for demanding this one. So this is what is the technology, advance of the technology help us to adopt this cyber physical systems. This is the significant achievement with the with your cyber physical system. You see, since 1990, the cost has been minimized to 16%, and in 2003 it has been reduced to 52% cost, and then 2010 it has been 56% was projected. It was projected in that one, but someday it will definitely achieve 99%. I should not say 100% because whatever if how far the technology has been advanced, there are always associated. It is each and every technology is associated with some threats. Okay, threats, and it is always associated with some drawbacks. For each and every technology, we have pros and cons. So even if we have some advantages associated with this CPS, there are also some of the drawbacks associated with this one. These are the things that we will discuss in our future slides. Okay. Now, in an example, in the year 1917 and 80, that it has reduced the aviation industry cost 10%. 10% cost is not less than. In current generation, it is going to nearly half of the cost. So next generation, it is expected that more than 50% of the project is going to be reduced. But whatever it is going to 99%. But still, we have to back up our mind that it cannot be completing for 100%. Okay, but as far as this growth of your artificial intelligence, as you all know that the artificial intelligence is proliferating like anything, or the technology has been exploiting like anything. So a day will come, definitely the technology, the robot, if you think of robotics or cobotics, they will definitely replace the human beings in your systems. It may be your avionic, or it may be your automobile system, and anything else. Okay, excuse me just a second. So these are what is the significance of your why one should adopt this cyber physical system. Okay, as you all know, then next computing, then whatever we are saying right now, the cyber physical system is what is the next generation computing system. We should not be confused about your revolution and evolution. Okay, now you think that we cannot, if we say that a cyber physical system is a revolution, then we are just making it a misnomer. Misnomer in the sense we are just making a mistake that naming some technology as a revolution. Rather, we should name it as a evolution. Why? Because evolution, as the technology has been advanced, the things, each and every day the things has been changed. If you just remember Moore's law, what the Moore's law says that? Moore's law says that in every 18 months, the architecture of your hardware changes. But it is very difficult to adapt, to design a software to cooperate with this hardware. Moore's law says that one. So this is only the drawback with the software. Okay, but it says that with each and every 18 months, the technology related to your hardware changes or evolve, new technologies comes out. Okay, in the early days we used to have a processor of 1600 megahertz. Now today is high-end processors we have, which is capacity of gigahertz, or high-end processor. We cannot name it. With the evolution of cloud computing and virtualization and all, we have high-end processor which can process billions of data in a minute or in a second. Okay, so this is what is the Moore's law says. In every 18 months, the hardware changes, but the software revolution need to be cope up with the changes in the hardware. Now, what I was exactly talking is the revolution. We cannot say that a computing as a revolution, because when we talk a revolution, we talk something about a revolution means it comes And a revolution means it replaces the existing technique and it survives for some days. Like that is what we say is the revolution. Evolution is the process. Evolution is the process. Each and every day new things come into the market and you have to be adjusted with the system. That's what is the revolution. So this particular cyber physical system is not a revolution, rather it's an evolution. Evolution in the sense each and every day new things has to be come and we have to adapt with the systems and with the surrounding. Otherwise we will be late and things will be going far away from us. Okay, so right from, if you just see the evolution of your computer technology, in early days mainframe used to work in the days of on 16 and 70, in the years of 16 and 70, when mainframe was there, it was a bigger size system and which process a huge amount of process data and in data for the data in it. But with the advance of our technology, we have desktop computing, where the big size computer has been replaced with a small size computer. It comes into the existence in the year of 18 to 19. This desktop used to work a lot, but with the advance of our technology, when in and around we have seen cloud computing, pay as you go, and advancement of your this following Moore's law, ASIC processor, and many more things. We have ubiquitous computing that come into the existing in the year of 2010. Whatever we are doing, seeing in and around us is ubiquitous computing. What is the advantage of it? Numerous computing devices. So numerous computing devices in and around us, and these devices are application specific in and around us. And we have millions of desktop or billion versus millions of embedded processors inside it. Okay. Now the current generation system, right from 2010 onwards, we have cyber physical systems, and this cyber physical systems is currently adopted in and around us. Okay. So now, what is the trends in our cyber physical system? In early days, there are three different trends that we have in and around us. Okay. The first trend is that embedded system. With the generation of your embedded system, we have adapted this cyber physical system into our system. Okay, with the advancement of your technology in embedded system, we have adapted this. This is one trend that works for your cyber physical system. Now, next thing is that integration of, now in early days we used to have mainframe systems. Now with the advancement of your technology, we have in and around us ubiquitous system. Wherever we say we have computing devices, wherever you just think of application. This is the second trend that works in your cyber physical system. First one is your embedded system. Second one is your ubiquitous embedded devices. Wherever we say, depending upon application, we have cyber physical system. The third thing is that with the biological evolution. Now you see there are three kinds of trends that work for the cyber physical system. The technology associated with the embedded system is exponentially increasing following the Moore's law, and the technology associated with the computing itself, right from mainframe, or it may be your desktop computing. Now it has moved to your cloud computing with high-end processor and everything. Everything is moving and exploring exponential, but this human being associated with this one is they are very still slow. Okay, they are still, so they are not coping up with the system. Yesterday, yes, human used to make error. Today also the human is to make errors. Yesterday, yes, human become tired us. We are tired us to do something. Today also they are become like that. So the efficiency of human being is remaining as it is, but other things that may be your ubiquitous company, that may be computing devices, or that may be your embedded is there. Excuse me. There is a disturbance, audio disturbance coming out.
So please keep on mute participants.
Yeah. Okay. So this is the drawback of why we should remove this human out of your automation industry, because everything is exploring, they are increasing, the efficiency is increasing. At the same time, the efficiency of your human being is also decreasing. So they are not following the Moore's law. Okay, so we have to think about removing this human intervention in our systems. Okay, then we have lot many applications of your cyber physical system. Just close your eyes, think of some application. It can be a cyber physical system. It's now there are there are a few to name, like your healthcare, or maybe your transportation, or it may be a process control, it may be a large scale, or it may be a defense system or telephysical system. So a broad category we can see that robotics. This is the broad way of defining your application. Okay, it may be robotics, automation, transportation, energy, whatever it is, in and around, whatever we see is just we can apply our CPS into that one. Okay. Now, what is the societal impact of your cyber physical system? Why should we adapt the cyber physical system into our day-to-day life? Why we should adopt this CPS in our society? If there is no advantage of this CPS, why should we adopt it? Okay, why should just remove human beings from this society? So there should be some advantage of adopting this technology in our society. The first and the foremost is that it says non-zero automotive traffic fatalities. As you all know that in and around us, so many accidents, traffic, because of fault with the traffic, so many accidents are occurring in and around us, and we are losing so many lives in day-to-day lives. Many are getting injured, and many more things are there. So if we design and so many, if we adopt this cyber physical system and define some technology for your traffic system, then we can also minimize. That's what is a significant of a cyber physical system in our day-to-day life. Now, the blackout of free electricity generation and distribution. Now, what happens? As you all know that today, if you go back 20 years, 30 years back, we used to have analog meters in and around us, and people used to go for stealing the electricity, and honestly, so many things used to happen. Okay, and because of that, so many lives has also been lost when the people used to put hooks on the wires, and they used to get the electricity to them. So for which we have no counts and we have no billing at all. Okay, sometimes doing this stealing the electricity may cause disasters in our society. So by implementing this automation system into the electricity generation, we can minimize stealing of electricity and the problem associated with electricity. Okay. Next point, important point, why should we adapt cyber physical system into our society is that perpetual life assistance. Okay, as you all know that today, if I want to go some places, I just have to on my GPS and see, just find out which place I have to go. I don't have to ask any people. I don't have to disturb anybody else. Simply, I have a smart system with me. I can use it and I can go for it. No, if I am feeling cough and cold, I just need some assistant, medical assistant. Just go for a mobile device and you find out what is the medicine for this one, or you can consult a physician in and around us. So you don't have to bother, think of anything. So we need to go get a perpetual life assistance by using this cyber physical system. So by using this CPS in our society, we can increase the productivity in our agriculture. Okay, we can make energy our building, because we can minimize the. Sometimes people when go out of their house, they do not switch off their electricity, and they don't take care of the electricity that is being consumed without in their absence. So adopting this cyber physical system, we can minimize the wastage of energy in and around us. Okay. And we can have location independent access to world-class medicine. Of course, it is there. Okay. Today, if I'm feeling anything, I can take help of a physician sitting here at India, and can go consult a physician sitting in America or wherever it is. I can order medicines right from anywhere else. So this is what location independent. Wherever you are, you can access it. We can. And the next point is that. We have a physical critical infrastructure that calls for preventive maintenance. Okay, self-correcting and self-certifying cyber physical system on and off applications, and reduce testing and integration time and cost. So there are so many things that can be minimized if we can adopt this cyber physical system into our day-to-day life. Okay, this is there are so many things for which we need to adopt the cyber physical system, but there are always, as I already told you, that there are always pros and cons associated with each and every technology. Okay, so first of all, we need to see that how far the technology is trustworthy. Whenever I talk about trustworthy, it should satisfy simple properties like reliability of the technology, security of the technology, privacy preserving of that one, and usability of that one. Okay, if if everything is coming with a particular technology, then I don't have any problem to adapt the things into my day-to-day life. So if I am adopting the cyber physical system, I need to see that whether the technology is trustworthy or not. The trustworthy signifies these are the properties. So if you just go back to the history, there are so many disasters that happens because of this cyber physical system. That means as I already that the pros and cons is associated with a particular technique, but it's not completely safe, or it cannot just adapt completely the things into our day-to-day life. There are some of the events that I would like to mention over here, which created a disaster in our life. There are some of the cyber physical systems that has created devastation, disaster in our day-to-day life. The first and the foremost, you can see that the Denver Vegas system, which is created a $300 million loss to them. Okay, then power blackout in New York in the year 2003. This is a great disaster. Then Ariane 5 in 1996. This is a great disaster. Mars Pathfinder, it was a cyber physical system, but once it is landed up to on the Mars, but it could not give us the climatic data that is there in your Mars. And for this project, many millions of dollars has been wasted, and this is a disaster. Then Mars Climate Orbiter. This is also, there are so many things. Cyber physical system. If you just Google it, because of this, there are so many cyber physical system that has created a history of devastation. Okay, so these are a few to name it. If I just keep all of them in this slide, then it will not set the capacity. Okay, so then we have so many challenges because we have so many disasters. Okay, already we have faced so many disasters in this cyber physical system. These are so many disasters we have faced in the cyber physical system. So we have so many challenges associated with this one. These challenges is what can be worked out for our resource problems. Okay, so what is the first and the foremost is the computation and abstraction. Whenever we are doing a computation, because it is an interdisciplinary systems, computation abstraction should be done, and novel real-time embedded system abstraction for CPS must be designed. And why the computation is very, very important? For whatever things you design, you should have a mathematical model for it. The mathematics plays a vital role. Whatever you do, we have to have a proper mathematical model, and in that mathematical model we need to define what is the input and what is the output. If this is perfectly clear, then everything should be 60% of the work is done perfectly, right? Everything, there is a technology associated with this one. Depending upon this thing, we can define the technology. Then we have compositionality, then we have system network and supports, and new foundation. Whatever we have, we can work on that one. Okay, then these are R&D needs and all the things that we need not to discuss. Then we have, as you all know, that if we talk about the CPS, it is only the software that helps us to adapt the cyber physical system into the society. But the good thing is that it is the software which does everything. The drawback is also that it is the software that creates a disaster for everything. So how it is possible now? You see that if you design a software, then it is associated with some security breach. It is associated with some security breach. Every system has comes with not a single system can guarantee that it can survive for a longer period of, or for a generation. Okay, it can survive only for 5 to 10 years. For each and every year, every security system lasts for only 5 to 10 years, not more than that. After that, what happens? Its security breach fails, and people can hack it, and people can create damage to a particular system. So because software is the part of your cyber physical system, we can adapt it, or we can at the same time the software can also create a disaster in your cyber physical systems. Okay, then these are some of the characteristic goal of your embedded software, because it is the embedded system that works behind your cyber physical system. So whenever, for each and every embedded system, we are coming out with a operating system, and with that operating system we are going to design a cyber physical systems. Okay, so these are the properties that we need to have for your embedded softwares.